This is question 499 from the Blue Book. I'm going to prove that modulus square of these two expression is equal to 1 plus modulus of AB square minus modulus of A plus modulus of B square. And for solving this question, I'm going to use this property. We used many times this one, z times z conjugate. If you remember, it's equal to z module square. So we are going to use this one here, 1 minus A conjugate times B square minus A minus B square. It's going to be equal to, now here there is modulus and I'm going to use conjugate form for this one, and it's going to be 1 minus A conjugate B times 1 minus A conjugate B conjugate minus here 1 A minus B times A minus B conjugate. It's going to be, I'm going to get a bit down and change the color to blue. Okay, then this is going to be equal to, firstly, one minus A conjugate B, it's going to repeat, only I'm going to get this conjugate sign inside. 1 minus A conjugate B times 1 minus A B conjugate. Then here I got A conjugate is equal to A, and I'm writing here that one. You remember that property, conjugate of conjugate, it's going to be equal to itself. So double conjugate we have here for this one. Then I got A. Okay, let me continue. Then minus A B times minus A conjugate B conjugate, it's going to be. Then it's going to be equal to minus 1 times minus 1. I'm going to use distribution law here. Minus 1 times 1, it's equal to 1. 1 times minus AB conjugate is equal to minus AB conjugate. And then minus A conjugate times B is equal to minus A conjugate B. Minus A conjugate B minus AB conjugate is equal to plus A conjugate B times, or all of them times A times B conjugate. Then here I'm going to keep this minus and I'm going to do this one in parentheses like this one. A times A conjugate, A times A conjugate, A times minus, not minus, plus, of course it's going, pardon, minus is going to be, because A times minus B conjugate, this is minus AB conjugate, and minus B times A conjugate, so it's going to be A conjugate minus A conjugate times B. Then the last one is going to be again plus B conjugate. Now I'm going to open this minus sign and I'm going to change the signs of all this expression. This part we don't have to do anything. I'm going to rewrite now A conjugate B plus A conjugate B plus, pardon, times A B conjugate minus, only at this part I can do this one also. Here I forgot to do that one. A times A conjugate times B conjugate. I arrange the places. I use the commutative rule. A minus A conjugate, minus and minus, it's going to be plus A B conjugate, and minus and minus, it's going to be plus then A conjugate B, and the last one again minus B conjugate, minus times plus, it's going to be minus. Then here there are some same terms with different signs. This one AB conjugate and plus AB conjugate, and A conjugate B and A conjugate B. I'm going to simplify, and here in this step I'm going to use this form again. Z times Z conjugate is equal to Z module square. So A times A conjugate, it's going to be like that. here is equal to 1 minus a times a conjugate, a times a conjugate, b times b conjugate, minus a conjugate, minus, actually this is plus, minus b conjugate. It's going to be, as I told you, I'm going to change, instead of these are module square, 1 plus a module square times b module square minus a module square and minus b module square. Now I'm going, this is the tricky part, and we are applying plus 2a module b module. Here I'm going to add, I'm going to rewrite this part, b module square minus a square minus b module square. This is the tricky part. I'm going to add 2 times a module times b module, and then I'm going to subtract 2 times a module times b module. It's going to be, and a module times b module, when I add 2a module b module, and when I subtract minus 2a module times b module, it's going to be equal to 1 plus 2a module times b module. I separate these two terms from each other and I put the first one here, plus a times b module parenthesis square. This is what, if I say this is x, 1 plus 2x plus x square. And if I get the second term in parentheses, minus parentheses, because all the other terms, minus a module square, minus b module square, minus 2ab module, is going to be equal to a module square plus 2 times a module times b module plus b module square. It's going to be, and for both of them I'm going to use the formula that you know, x plus y squared is equal to x squared plus 2xy plus y squared. This is 1 squared plus 2 times 1 times 2 times 1 times a times b module, then a times b module square. This is x, this one is y, this is y here, this is y square, this is x square, and where is the x here? 2 times x times y. It is because 1 is invisible coefficient here. Okay, then this is going to be equal to, it's same for this one, but this is more easier than the first one. That's why I showed on the first one. Then this is going to be 1 plus a module times b module square and minus in parentheses module of a plus module of b squared. It's going to be, and it is the proof of the solution.